Today we'll be talking about ratios and similar polygons. The vocabulary for today is similar, similar polygons, and similarity ratio. Figures that are similar have the same shape but not necessarily the same size, and we'll be using that small swoosh sign that looks like the top of a congruent symbol as the symbol for similarity. Triangle 1 is similar to triangle 2, which can be written triangle 1 similar to triangle 2 in the parentheses. Triangle 1 on the right is not similar to triangle 3 because they don't have the same shape. One is a right triangle and the other one is an acute triangle. The two polygons are similar polygons if and only if their corresponding angles are congruent and their corresponding side lengths are proportional. Remember, a proportion is when you can set up two fractions equal to each other. So in our picture here we have polygon ABCD and polygon EFGH, and all of the angles are congruent, just like in a congruent polygon, but the sides, rather than being congruent, are proportional. And in the example they've given here, the proportionality constant is 1/2. Here we're going to identify the pairs of congruent angles and corresponding sides. So our corresponding angles are N and Q, because they're both right angles, P and R, they're both 63, and M and T, because if two angles are congruent, then the third angle must be congruent. So that's our third angle theorem. We can also find the proportional sides. MP to TR is 2.2 over 1.1, which gives us 2. MN to TQ is 2 to 1, which is 2. And NP to QR is 1 to 0.5, which is also 2. So we can see that they are similar because the angles are congruent and all of the sides are proportional. We're also going to identify the pairs of congruent angles and corresponding sides in these two triangles. B and G are corresponding and congruent because they're both 90 degrees. C and H are congruent because they're both 59 degrees. And A and J, by the third angle theorem, are also congruent. AB and JG are proportional, 10 to 5, which is the same as 2. BC and GH, 6 to 3, which is 2. And AC to JH, which is 11.6 to 5.8, which is also 2. So they are going to be a pair of similar triangles. A similarity ratio is the ratio of the lengths of the corresponding sides of two similar polygons. The similarity ratio of ABC to DEF is 3 over 6, or 1/2. The similarity ratio from DEF to ABC is 6 over 3, or 2. Notice that in each of these examples, the triangle that's listed first goes on the top of the fraction or the numerator, and the one that's listed second is the denominator. So it does matter which one's listed first because that will change your similarity ratio. Writing a similarity statement is like writing a congruent statement. Be sure to list corresponding vertices in the same order. For this example, we're going to determine whether the polygons are similar. If so, write the similarity ratio and a similarity statement. So we're looking at triangle PQR and triangle STW. First, we identify pairs of congruent angles. The base angles PR and SW are congruent because they are two isosceles triangles. If we compare corresponding angles, measure of angle P is equal to the measure of angle R, which is equal to 1/2 of 180 minus 36. So each of the base angles in the first triangle are 72 degrees. The measure of angle W and the measure of angle S are the same and equal to 62. And we know that the vertex angle of that isosceles triangle is 56. So we have no pairs of angles that are congruent, so the triangles cannot be similar because for similar triangles we need to have 3 congruent angles for a triangle. Here we want to determine if triangle JLM is congruent or similar to triangle NPS. If so, write the similarity ratio and a similarity statement. First, we identify pairs of congruent angles. N is congruent to M because they're both right angles. L is congruent to P because they're marked as congruent in our picture with that curved line. And S is congruent to J by the third angle theorem. Now we compare the corresponding sides. LJ to PS is 75 over 30, and that reduces to 5 over 2. LM to PN is 60 over 24, which reduces to 5 over 2, and JM to SN is 45 over 18, which also reduces to 5 over 2. Therefore, the similarity ratio is 5 over 2, and triangle LMJ is congruent, or of course, similar to PNS. When you work with proportions, be sure the ratios compare to corresponding numbers. Here's your lesson quiz. Go ahead and practice these, and we'll go over them tomorrow if you have any questions. And please make sure that you understand all the material from the slides so that we can continue on with some practice tomorrow.